Hey everybody, it's Danny from the Small Venue Survivalist, and checking in to say, first of all, thank you for the positive responses on my video. Looks like I'm going to keep trying this little experiment and see where it goes. Anyway, last time I mentioned in part of the video that the decibel, or decibel, however you want to say it, is a whole topic unto itself. Well, today I'm going to address that topic. Oh, and I'm going to kind of do it in like a 1950s film strip kind of way. So let me know what you think of that. Here we go. The Small Venue Survivalist presents The Decibel and You. The decibel. What is it? The decibel is a non-linear unit of measure created by Bell Telephone Laboratories. In telecommunication systems and professional audio applications, it is often necessary to compare large differences in measured power. This can be inconvenient with linear units. The decibel solves this problem using a logarithmic scale. No, not fat beats being produced by striking a piece of wood at regular intervals. Rather, the logarithm. The inverse of an exponent. Logarithmic scales compact large, linear ranges of values into a much more manageable form. The logarithm used by the decibel is concerned with powers of 10. Hence, it is a base 10 logarithm. Be sure that any decibel calculations you perform use a base 10 logarithm. Some mathematics systems default to the natural logarithm instead. The decibel is a unit that describes a power ratio. As such, you should be aware of three main rules for the use of this unit. First, that the decibel has no meaning unless a reference point is designated. Second, this reference point is the denominator for the ratio and thus must not be zero. Third, logarithms are only valid for ratios with a positive value. A decibel value can be negative, but the input ratio must not be. All sorts of reference points for decibels exist. There is dBW, which references 1 watt of power. There is dBu, which references 0.775 volts root mean square, unterminated. There is dBSPL, which references 20 micropascals, the threshold of human hearing at 1 kilohertz. For a power ratio, the decibel value is 10 times the base 10 logarithm of the ratio. A ratio of 1, that is, the reference point itself, is always 0 decibels. Ratios greater than 1 give positive decibel values, whereas ratios less than 1 give negative results. But wait, you say. Professional audio is often concerned with voltage, yet the decibel is concerned with power. How can we square that circle? Remember that voltage can be related to power in various ways. One such form is this. Power equals voltage squared over resistance. Because we are concerned with the ratio of voltages and not the actual power value, we can set the resistances as being equal to 1. This leaves us with voltage squared over voltage squared. This may seem clumsy to calculate, but never fear. The same result may be obtained by multiplying the base 10 logarithm of the simple voltage ratio by 20 instead of 10. Isn't that swell? The decibel is a versatile unit of measure that can be adapted to many needs in the professional audio world. Know it, and use it well. Thanks again for watching, everybody. I just wanted to let you know again that Patreon helps me keep doing the things that I do. And if everybody who was interested in any way in anything that I do put in $1 a month, that would have a huge effect. So please consider it. Cheers.